In the previous lesson, we discussed RSA encryption and decryption. And just like what we discussed in AES ECB mode, this RSA encryption decryption, as given in the formula here, also have the same deterministic problem. Deterministic problem means that the same message will always result in the same ciphertext. And in that case, it is said to be not secure according to strong security principle. Let me give you a reason why in this context of RSA encryption. Notice that we have discussed that in the case of using asymmetric encryption, the public key is known by public. So it can be that the attacker use the known public key and choose likely plaintext and pre-encrypt them. So he can select several plaintexts and then encrypt them so that in the case that he is able to intercept a ciphertext, then he can simply just compare the pre-encrypted ciphertext versus the stolen ciphertext. And if he found a match, then a corresponding plaintext to the stolen ciphertext is discovered. And such an attack is known as chosen plaintext attack. And this attack is possible because of the deterministic problem. Because the same message, the same plaintext will always result in the same ciphertext if we are using the original formula of encryption and decryption of RSA. So just like before, in the case of AES ECB, there is a way to address this problem by using randomization. So essentially, RSA with random padding requires that you apply a random padding on the given plaintext message so that the same message encrypted multiple times will look different each time. So technically, it is straightforward. So generate a random value, a random padding, which is a random value simply, concatenate with a given plaintext, and only do the encryption of the resulting value. So the rest is the same as before, encrypting using RSA. And decrypting is still the same processes involved, but the thing is, after decrypting, the value that you get is the random padding concatenated with the original plaintext message. It means that to get back the original plaintext value, you need to discard the decrypted value, which is simply a matter of removing the very first set of value, which is equal to the size of the random padding that you used. According to the public standards called PKCS, the size of the random padding that you use is 34 bytes. Here, there is one very important property, or rather limitation of RSA. The size of n range from 2048 bits, which is equivalent to 256 bits. But assume that it is using this 2048 bits. The limitation here is that the size of P can only be maximum 222 bytes, which is 256 minus 34, and 34 here is the size of the random padding that you use. It is because of this property, which we discussed earlier, because of the modulus n, that means this R concatenate P is in fact a remainder of C exponential D modulus n. That means this value can never be bigger than the divisor, which is n here. So essentially it means that your message can only be maximum size 222 bytes. So it means that ISA is only appropriate for encrypting small size data, which is not very big. And the question here is, what happens if you need to encrypt a larger size message, P greater than 222 bytes? And the answer is to use hybrid encryption, and we will discuss that in the next lesson. Thank you very much. See you next time.